Okay, so let the test begin right now. So here we have RAG, and here we have fine-tuning. So let's ask questions and let's see how they respond. Who is the Vice President of the United States of America?
As of May 2025, the Vice President of the United States is J.D. Vance. He was inaugurated on January.
Who is the Vice President of the United States of America?
As of May 2025, the Vice President of the United States is Kamala Harris. Please check the latest sources for the most up-to-date.
Who is the President of Canada? Sorry, who is the Prime Minister of Canada?
As of May 2025, the Prime Minister of Canada is Mark Carney. He was the elected leader of the Liberal Party and sworn in as Prime Minister on March 14th.
Who is the Prime Minister of Canada?
As of now, the Prime Minister of Canada is Justin Trudeau.
Okay, so you see the simple exercise. We see that for RAG, it provides the most up-to-date response, but for fine-tuned model, it provides the response based on the last time the model was fine-tuned. So at this point, you might be asking, okay, RAG should be the best, right? Why should we worry about fine-tuning when we can just use RAG, right? That's a valid question, and I'm going to answer that question in a few minutes. But before we answer that question, let's take a minute to understand the difference between RAG and fine-tuning as it relates to large language models. So let's take the first one, RAG. So we have RAG. So this stands for Retrieval-Augmented Generation, and it means that the large language model is going to search for external knowledge base to retrieve additional information in addition to what data is used to train the model. So it can be represented like this. So for RAG, we have you. So you are asking a question, and we have the large language model right here, okay? So we have the LLM, and we have the user. So what happens in an RAG-based system is that your prompt is going to hit what we call the RAG agent. So this RAG agent is responsible for negotiating between the large language model and the user, and this RAG also interfaces with external data source, which could be the open internet. It could also be your local knowledge base. It could be some intranet site. It could be a collection of documents in a file share, whatever it is, but it's some external data store. So when you make a prompt, your prompt goes to the RAG agent. It's going to take your prompt and it's going to search the knowledge base. It's going to search this knowledge base and it's going to retrieve relevant information exactly the same way we do when we search for information in Google. It's going to retrieve the relevant information. It's going to now prepare this information and add it to the payload that goes to the LLM. So here we now have your prompt plus the retrieved information goes to the LLM. So the data coming from the knowledge base is added as a contextual information to enrich your prompt, and then you get an enriched response that goes back to you. Now this is exactly how RAG works on the high level. I provided a detail of this in my website. You can find the link in the description of this video. Let's now look at the next one, and that is fine-tuning. So fine-tuning is another way to update the data provided by a large language model. So what does fine-tuning mean? Fine-tuning means that you have to train or retrain this large language model using new data set. So let's say this language model was created in 2025, let's say May 2025, and this is May 2026. So there are new information that is now available between May 2025 and May 2026. You have to use this information to retrain this large language model and redeploy it to production, and it becomes just one single unit of LLM. So basically you have you right here, and we don't have an agent, we simply have a large language model that this time is a little bigger, right? So it's a little bigger than the previous one, right? So you have a bigger language model this time containing additional information, this time from 2025 plus 2026, right? So you have these two information. It also means that when 2027 comes, you have to update this language model again at some point. In this case, this model gets up-to-date information from wherever the information sits, whether it's the open internet or it's your local repository of your organization. It gets this information and sends it across to you. So we don't have an agent in between, we simply have communication between these two. Okay, so let's answer the main question. Let's evaluate the RAG and fine-tuning based on the 6 criteria, and for each of them, we are going to write out the winner at this point. Let's start from the first one, cost. Now let's look at RAG. RAG, it could be that you have a very small language model, a very small large language model. And this is a low-cost language model, right? It's not heavy, it's very small. You can install it in a very low-end system, and the cost is very low. And then you augment it with RAG, searching the internet or searching the information repository you have takes nothing. So basically, the cost of using RAG implemented system is very low compared to having a generic large language model that provides all the information within a single LLM unit. So in this case, the winner here is RAG. Let's look at the speed. So in case of the RAG, it makes a hop into the knowledge base, back into the agent, to the language model, back into the agent, and back to the user. So clearly you can see that RAG-enabled system takes a longer time to provide a response to the user, and therefore the speed, the perceived speed by the user is very low. Not very low, but relative to a fine-tuned model where all the information is available in the model, this provides a lower quality response in terms of the speed or the response time. So in this case, we have fine-tuning wins. The winner here is fine-tuning. Let's look at privacy. Now, when you talk about privacy, for an RAG system, you could have your private data, critical data, maybe proprietary data of your organization sitting in your company. It doesn't have to go out to the open internet or to any language model. You have it sitting there. And you have your RAG agents accessing this information right within your organization. So it doesn't have to go to external data source or the open internet to fetch this information. And you don't need to send this information, this proprietary sensitive data, to the language model for training, because you simply have to have it as it is in your organization, in your file system, in your database. So it doesn't have to leave your system or your organization, so it's secure and private. So in this case, we have RAG providing a very good advantage. But if you also think about fine-tuning, you could also have a small large language model. You obtain this small large language model and have it deployed internally, and you can train it using your proprietary data and have this small large language model trained only using your proprietary data, and it's not available to the public. So in this case, fine-tuning also provides the needed privacy. So in case of privacy, we can have, in this case, it's a draw. So both of them performs good depending on the customization for specific needs. Let's now look at the quality of data. Now, the test I was doing at the outset of this video, where I ask a question, this is a test of the data quality. In this case, the language model that is fine-tuned last year in 2025 provides a low-quality data or a low-quality result, which is not accurate. The current Prime Minister of Canada is not Justin Trudeau, right? So the quality of data is higher when we have RAG, because this accesses the up-to-date information from the open internet or from the public repository. So in case of quality, we have RAG providing an up-to-date information, while the fine-tuning provides information that is up-to-date, up to the point it was trained. So for quality, we have RAG is the winner here as well. Let's look at the maintenance, right? So what does it cost to maintain a large language model in terms of continuously fine-tuning this large language model? Now, it takes a lot of funds, so let's try to find out how much it costs. How much does it cost approximately in terms of US dollars and time to fine-tune a 70 billion large language model? Give me a rough estimate without analysis, please.
To fine-tune a 70 billion parameter large language model, it could take approximately 2 to 4 weeks and cost around 100,000 to 300,000 in US dollars.
So you can see that only fine-tuning, right, can take 100,000 to 300,000. This is approximately, of course, it depends on a number of factors, but this amount is really high. Imagine you want to keep your model up to date by months. Every month you spend this amount. This is ridiculously high amounts to be able to keep your model up to date. So maintenance cost is very high for fine-tuned, and definitely for RAG is lower because you have a real-time retrieval without having to spend this amount for fine-tuning or retraining. So here we have again that RAG wins the fight here. Let's now look at the last one, transparency. So transparency means having to provide how you got this information. So basically, if you ask a large language model for information, it's going to tell you, it should tell you where it got this information from. For a fine-tuned model, this feature is not there. So fine-tuned model takes this information and bakes it into the model's parameters, and it loses the source of this information. So the source of this information is lost when you have a fine-tuned large language model for the basic part. But for the RAG, any information retrieved, it can tag this information with the source of the information. So you basically have the RAG-enabled system providing you with the source of the information. So it gives you a higher level of transparency compared to fine-tuned large language model. And in case of transparency, RAG wins. So you can see that at this point, RAG basically wins. And this is not a surprise because RAG is what is applied most times, even in the ChatGPT or every other chat agent or LLM agent you see out there. It has a combination of fine-tuning and RAG augmentation, or RAG, right? So this is what we have in the real-world scenario. RAG is always used in many of the systems. All these details is provided in my website. I'm going to display this table of comparison. So take some time to spend looking at this table. Also visit my website to see how I provided all the details about this criteria and how they compare, and also the use cases of RAG versus fine-tuning. So I'm going to be stopping here. I'd like to thank you for viewing. I'd like to thank you for visiting my channel. Remember to subscribe so that you don't miss any updates from me. If this video has also been informative, like it, and also leave me a comment if you have any topic you want me to discuss. I remain Kindson the Tech Pro, and I'm always there for you.